Hello and welcome to UC Irvine Extension's Introduction to Predictive Analytics course. I'm Eric Siegel and I'll be presenting a few lectures in the first few weeks of the class. Here's a little information about me. I'm the founder of Predictive Analytics World and Text Analytics World, which are the leading events, they're conferences, in the commercial deployment of these technologies. Check out the websites for details. They take place several times a year. You can see the full agendas, programs, cities, and dates. Also know that full-time students and faculty members are eligible for a 50% discount on registration fees. I'm also the executive editor of the Predictive Analytics Times, which is the Predictive Analytics Professionals' premier resource. Lots of great content there, news articles and such. Check us out on predictiveanalyticstimes.com. My consultancy is Prediction Impact, and I'm a former Columbia University professor in the computer science department, where I focused on machine learning technology. I am the author of the book Predictive Analytics, The Power to Predict Who Will Click, Buy, Lie, or Die. There's that subtitle right there. It gives you a broad definition of predictive analytics. This book serves as one of the textbooks for this class. And as a reminder, one of the homework assignments for the first week of the class is to read chapters 1 to 4 of the book and also review the color tables, numbers 1 through 9, in the middle section, that is the color insert of the book. For more, by the way, check out the book's website, thepredictionbook.com, for excerpts, articles, reviews, and videos. Now, when you look at the table of contents, you will see relatively entertaining titles for the chapters, and mentioning brand name companies like Hewlett-Packard. But let me point out, since this is being used as a textbook for the course, the conceptual outline of the book. So these are the actual concepts covered by the chapters. The book really is conceptually complete, so certainly serves as an introductory textbook. However, it's in disguise as a more entertaining pop science book, meant to be very accessible and more entertaining and conducive to read. Lots of specific case studies, and we worked on the flow so that any reader out there might take enjoyment, people who like books like Freakonomics. But in terms of being conceptually complete, here is the outline. The introduction chapter covers the basic concepts. Chapter 1 focuses on deployment. That means actually putting a predictive model and its predictions into play, changing the actions and operations of an organization based on the predictions. That's where the value actually comes, making use of the output of a predictive model. Chapter 2 covers the ethical issues that come up when you deploy a predictive model, when you use this technology, both with regard to privacy and other civil liberty concerns. Chapter 3 is on data, where it all comes from, and why it's so darn predictive. That's the resource we're leveraging with predictive modeling. Chapter 4 is on the core technology. Predictive modeling specifically gets into decision trees in some detail there. This is the process to learn from data how to predict, predictive modeling. Chapter 5 is on what's called ensemble models, an advanced method that sort of supercharges predictive models. It's one way to make predictive models more effective, more predictively precise, and robust. Chapter 6 is on IBM's Watson computer, which answers questions on the TV quiz show Jeopardy, and on how it uses predictive modeling at the core in order to answer the questions on that TV quiz show. Chapter 7 is on the theme of influence or persuasion. That is, you predict persuasion in order to do persuasion. So it's an advanced form of predictive modeling that's predicting the influence or persuasion that can take place in marketing and other application. The 2012 Obama campaign analytics team used this, and there's a sidebar on that topic. So it's very much an advanced method, but a quite intriguing one, both from the technology standpoint and practical standpoints. So I hope you enjoy the book. Today I'm going to talk about predictive analytics and how it delivers value for marketing. So today this is a general introduction to predictive analytics, but focusing specifically on marketing applications. And you'll see when you go to to the rest of the course and other lectures from me and other instructors, that really the technology applies more broadly. Within the business realm, outside of marketing, there's credit scoring, there's fraud detection, and then there's many other applications outside of business applications. So predictive analytics is very much a broadly applicable technology. Today, with regard to marketing, we'll focus mostly on two application areas: response modeling for acquisition, that is predicting who's going to respond in order to target direct marketing, and churn modeling, predicting who's going to leave, churn, attrite, defect, essentially synonyms, in order to target retention, to try to keep those customers around. And I'll cover the basics on how predictive analytics works and some case studies. So what is predictive analytics? You know, there's no better known prognostic quant, no more famous person of prediction than Nate Silver, formerly New York Times blogger, more recently moving to ESPN, and a political poll aggregator. Nate Silver correctly predicted for each of the 50 states the outcome of the 2012 presidential elections. So for each state, he was able to correctly predict ahead of time which way they would vote. So people ask, you know, was that predictive analytics? Did he use predictive analytics to do that? And the answer is no. But Obama did use predictive analytics, and the difference between the two endeavors illustrates the distinction between forecasting and predictive analytics. So what Nate Silver did was forecasting. So within a state like Ohio here, what's the overall trend in aggregate across voters? Overall, what's the propensity to vote for one candidate versus the other? Versus the Obama campaign, who produced predictions for each individual voter with predictive analytics. Now you might imagine what they did was predict which direction each voter was going to go, but actually what the Obama campaign did was endeavor with the more advanced persuasion modeling, also known as uplift modeling, that's covered in the final chapter, chapter 7 of my book, Predictive Analytics. That is to predict for each voter who's influenceable or not. Who can we actually persuade to vote in our direction for our presidential candidate by way of campaign contact? In particular, these predictions were used to target the use of the limited resources that this marketing endeavor did, right? Selling a presidential campaign is a marketing endeavor like any other. The limited resource being the campaign volunteers, who were given lists of exactly whose door to knock on, whose phone number to call, and then for direct mail, who gets brochures in the mail. According to those, voters predicted most likely to be persuadable, to turn out more votes for the candidate, right? Very much analogous to any other marketing campaign where you're trying to turn out actual purchases of your product. In that case, the limited resource is more about budget for these campaign activities. So, in summary, while Nate Silver competed very publicly to win at predicting the outcome of the election in aggregate with forecasting, the Obama campaign's analytics team competed very quietly to win the presidential election itself. Which is more powerful, winning the presidency or winning at prediction thereof? And this illustrates what it means to go to that level of granularity, per person predictions, the defining characteristic of predictive analytics, which enables you not only to predict the future, but to influence the future, because the predictive scores per individual directly inform the operational decisions per individual, so make things run more effectively. And in that way, predictive analytics very much is the holy grail for marketing and other applications. What could be better than knowing the potential needs, purchases, responses, or cancellations of each individual customer? So that's the definition of predictive analytics: technology that learns from experience. Experience is data. So by the word experience, I'm referring to data. Data oftentimes conjures boring images of ones and zeros, but it's not boring because data is actually an encoding of things that have happened. It's a recording of the history that's been aggregated by an organization. And in that sense, it's the aggregate or collective experience of the organization. So predictive analytics is a technology that learns from that experience to predict the future behavior of each individual. So on the bottom you see a bunch of individual people. Now there are other applications where it's individual product or individual store. Many of the application examples, and those I'll be emphasizing today, are individual people. Each person gets their own predictive score, the number. The higher the number, the higher expected chance that the individual will perform a certain action, whatever is being predicted at this moment, at this particular project of this particular deployment of predictive analytics, such as whether you're going to click, buy, lie, or die, as in the title of my book, whether you're going to cancel your order, cancel your subscription, whether you're moving beyond marketing, whether you're going to become sick for healthcare applications, whether you're going to commit an act of fraud, etc., etc. Any kind of behavior for which it may be valuable for the organization to predict in order to drive better decisions, such as whether to contact, expend the cost to contact with direct mail or a phone call in the case of marketing applications, whether to offer retention, these kinds of per individual decisions. So data comes in from the left. The core technology, predictive modeling, once it's set up and ready to go, is an automated process. That is to say, it's algorithmic. There's a computer program that does it. You push go, and it learns from that data to produce a predictive model, which in this slideshow and within the book is depicted as a golden egg. Now in the book's black and white, so the egg's not gold, but it's just as valuable. It's a predictive golden egg. It's a predictive model, and the job of that thing is to make the predictions per each individual. So the whole point of this learning process, the modeling process, is to derive a mechanism that knows how to look at one individual and take the characteristics known about the individual, demographic, behavioral, etc., to consider them collectively in concert to produce that one individual predictive score for the thing at hand that's being predicted. So you're looking at a customer today, you're saying, hey, if I offered this customer, if I solicit them with this brochure, what are the chances that tomorrow they will have a positive outcome, they'll buy the product? Now, an often overlooked question is, well, what if I suppress them from my direct mail? What if I didn't contact them at all and saved that little cost of contact for that one individual? Would they potentially make the purchase anyway? That's a secondary question. Actually comes up with the persuasion modeling, uplift modeling of chapter 7. So that's quite an advanced topic. So, you know, prediction all sounds well and good. Certainly would be valuable, but isn't it audacious? Isn't prediction impossible? The only thing we're certain of is uncertainty. Niels Bohr, Nobel Prize winning physicist, is quoted as saying, prediction is very difficult, especially if it's about the future. Jay Leno, how come you never see a headline like "Psychic Wins Lottery"? Well, the bottom line, the thing that adds credibility here, is that in fact you don't have to predict accurately to produce value. This is oftentimes about predicting better, significantly better than guessing. By doing that, you improve and render more effective the millions of operational decisions, per person decisions, that are made by organizations, such as within marketing. Here's an example. Let's say we're doing direct mail to this list of customers with 1 million people on the list. Every time I decide to contact someone, I expend the cost to contact $2. For those rare people who don't just consider it junk mail and actually respond and make a purchase, I'm going to make a profit after fulfillment of $220 minus the cost of contact, so it's actually $218. So let's do some arithmetic. If in fact, as is often the case, the response rate is 1%, that means 10,000 of these people are going to actually respond. The arithmetic shows $200,000 profit. Why? Because first you spend $2 per contact, that's $2 million. Then you've got 10,000, each of whom profit 220, that's 2.2 million. So 2.2 minus 2 is 0.2, so 0.2 million, $200,000. However, wouldn't it be great if we could use prediction to improve and make more effective this direct mail campaign. So let's say we score each individual with a predictive model according to those more or less likely to respond if contacted. And when we order the list by score and we take the top quarter, the top 25%, those 250,000 turns out have a 3% response rate. Well, from a marketing standpoint, that's quite exciting. This is a real hot pocket. They're on average 3 times more likely than average to respond. If we only do direct mail to that portion of the list, do the same kind of arithmetic, and it turns out your profit has skyrocketed by a factor of more than 5 to $1.15 million. So that's great. So great that I actually paid my designer to make this star graphic. Just to emphasize how exciting, that's a big deal, obviously, and we got all of that simply by suppressing those 75% considered significantly less likely than average to actually respond if contacted. However, you know, this predictive model stinks. Why? If it's not accurate. Even in that hot pocket, everyone as an individual, at least on average, has a 3% perceived probability of responding based on what we know about them on average. Some will have higher. But the fact is, in general, we don't have high confidence about any one individual to say, hey, this person definitely will make the purchase. It's not a crystal ball. But it's a skunk with bling because quite valuable. I call this the prediction effect. A little prediction goes a long way. Predicting better than guessing provides great value for organization's operations. So how does predictive analytics work? If you saw Kung Fu Panda, you know the old wise turtle who taught that panda on the left everything he knew, voiced by Dustin Hoffman, said, yesterday is history, tomorrow is a mystery, but today is a gift. That's why it's called the present. Okay, well, to take a slightly less sentimental or philosophical view and a little more hard-nosed practical view, well, what is it that we have today in the present that is a valuable resource with which to predict? And typically we're looking at stuff we know today to try to predict tomorrow. That's the Holy Grail concept. But let's look at what we have in a pocket already that we also already know without having to make prediction. We have yesterday relative to today, and we have data about a customer that we decided to contact yesterday based on what we knew about him or her, and found out today whether, after waiting around until today, whether they had a positive outcome, purchased the product or not. So we have this one row of data for that customer. On the left of the dotted line is the stuff we knew at the time of making the decision to contact them. They were male, they live in California, they made 10 purchases so far, etc., etc. Then after waiting around, we find out, yes, they did respond. Now, all this information is in the past. There's nothing that actually needs to be predicted, but it's a learning case. It's a row of data on what's called training data. So it's all in the past, but it's from 2 different points in time. And that dotted line is just a conceptual distinction that only you, who's familiar with your organization's data and putting your data into this form and format, really knows. There's nothing technically different about different items of data, but you know because of the meaning of the data and how you arranged it and took what exists and put it into this form of format, where each row looks like that. And of course the data is much wider because we may have lots of elements of data, but the list of elements we have about the customer, the predictor variables, the things on the left of the dotted line, it's just a list of them. So it's just a one-dimensional single row of data, and since we have one row per customer, it's just a flat table. It could be one table in a relational database, it could be an Excel spreadsheet, you could write on a huge piece of paper, but it's 2-dimensional, it's just a table, and that's the form of format in which you must get your data in order to input into any predictive analytics software. There's lots of different types of predictive analytics software and lots of options and lots of companies selling it and free solutions. But none of them will automate this because it's based on knowledge and understanding of the meaning of the content of your current data and how to get it into this form and format. It's sort of a database programming task. So everything I've just said here about that training data form and format, it already is sort of 85% of what you really need to know about data preparation, that is putting the data into this form format ready to learn from it. Now once you do, you start looking at individual elements. Let's say one way or another, one at a time, to see which is predictive. So a couple examples. There's a classic data mining example, often considered urban legend, but actually based on a real retail example, where people buying diapers at a certain store were actually more likely than average to also buy beer. So people could interpret this as, quote, daddy needs a beer. But regardless of the interpretation or the sense of causality, the fact is these two elements were connected, and therefore the purchase of diaper was predictive of purchase of beer. Second example, just the domain name of the email address can be really predictive. So when you strip off everything before the @ sign, it turns out in this case for an online dating site where people had free memberships, the probability you would subsequently convert to upgrade to a paying premium level membership varied greatly just based on this one data element. From 0.5% up to 2.5, a 5-fold rate just based on email address, where the less responsive or less converting email addresses were free email addresses like Yahoo and Hotmail, potentially where people had not been committed, they'd given their sort of temporary free or anonymous email address, up to Earthlink and SBC Global, which were potentially people's main or permanent email addresses. That's an interpretation. Regardless of causality or ways to interpret it, the fact is it was predictively valuable. Just that one piece of data. When you're looking at something like this, just one variable about the customer, and it makes that big a difference, that's great news. You've already gotten a predictive boost just based on one element, and ultimately the predictive model's job is to consider multiple things in concert together to produce the predictive score. So it's going to learn from data how to basically combine multiple variables. It's a multivariate model. But you find this kind of thing over and over again. All these are usually, you've got lots of pieces of data, and a good number of them, or at least a few, really turn out to be quite predictive, valuable, show predictively valuable correlations. Data is predictive. You just keep finding this kind of thing over and over again. Relationships, some of which seem intuitive, others are surprising, but the fact is data speaks. It's extremely valuable. This is why there's a lot of excitement about, quote, big data, which is more about the big excitement rather than the size of the data, although data can get quite large, and the bigger it is, the better from an analytical standpoint. More data from which to learn. So it works, and here's a few examples. First Tennessee Bank showed that by predicting who's going to respond to direct mail, they were able to lower the direct mailing costs by 20% and increase the response rate by more than 3%, which resulted in a 6-fold return on investment for that predictive analytics initiative. Target reported improved direct mail targeting by 15 to 20% using predictive modeling. Premier Bank Card reduced mailing costs by 12 million, presumably by suppressing those customers much less likely to respond. Not just large organizations, healthcare, small businesses, nonprofits. For example, Harbor Suites was able to reactivate lapsed buyers, people from whom they had not received business for a while, and were able to learn the right segments for a particular marketing offer and get an amazing, unprecedented 40% response rate amongst those. I'm not familiar with the details of this. Maybe they were offering them free chocolate, but you can see the references to these at the end of the book, Predictive Analytics. So far what I've been talking about is targeting direct mail and direct marketing, that is by predicting who's going to respond if contacted. It goes beyond that in terms of how to use prediction. For example, there are some cases where it's not about deciding whether to contact or not, but you know you are going to contact, and it's about what content, which ad to show, which product to recommend, this kind of decision. And in that realm, marketing is kind of a good model for dating. Or you could look at it the other way around. Dating is a nice model for marketing. So you're not sitting here in the restaurant for food. It's a sales call. You're selling yourself. You're both the director of marketing and the product. It's very important to predict which message is going to lead to a positive outcome and which is going to lead to a negative outcome. For example, in this movie shown, Groundhog Day, starring Bill Murray and Andie MacDowell. If you've not seen the movie, I'll just, no pressure, but when I ask a predictive analytics audience, almost everybody's hand goes up and everyone's enthusiastic. Everyone loves this movie. It's hilarious. And in the movie, Bill Murray is stuck reliving the same droll day over and over again. He is a real narcissistic TV personality, and it seems like it's a punishment for that. It's the holiday Groundhog Day, and he just can't get out of it. He's just reliving the same day over and over again, and he's kind of in his own little hell until he realizes that this provides him the unprecedented, almost superpower of opportunity to test different marketing treatments on the same subject under exactly the same circumstances to see which leads to the best outcome. So, for example, in this scene in the restaurant where he's on the date with Andie MacDowell, he goes, "So you didn't always study journalism when you were in college?" "No, actually," she says, "I was a French poetry major." And then he blurts out, "Oh, what a waste of time!" And she gets upset. Well, for other people, it'd be a waste of time. You must be a really strong person. But he knows he's ruined his chance. The scene starts again, over again, because that's what he keeps doing. So he always can do a retry. So he gets to this point in time, and this time things go different. "So you weren't always a journalism major?" "No, actually, I studied French poetry." He takes a deep breath and pause, and he goes, "Je m'appelle quel fromage." He doesn't say "Je m'appelle quel fromage," but he speaks French. He says this beautiful French poetry, and she's dumbfounded, and she says, "You speak French?" Oops. And his response, "Way." Great. So she's super impressed. He speaks French correctly. Unfortunately, in real life, we don't get do-overs. And the best we can do, the only recourse, is to predict which treatment is going to have the best outcome. For example, picking which ad. Which ad is going to result in a positive response by the viewer, the user. One project that I led on the analytical side for a education portal, which has sort of a corner on the market of providing information about grants and scholarships to people headed to college and also to graduate school. 1 in 3 college-bound high school seniors will use this website. It shows banner ads like this. This is an interstitial. It takes over the whole page. And the choice of which ad to show isn't based on the data that you see it's asking them to type in the middle here, but rather the data it already has about the user in order to predict, is this ad the one we should show, or is there one of the other ads? So there were about 200 and something ads, and in a head-to-head A/B deployment, comparing the existing legacy system, not based on prediction, but simply based on acceptance or response rates. That is the ones that are most responded to overall, most popular, most commonly clicked correctly, positively by the users. Versus the system that we integrated, model-based, based on predictive model that says, hey, we think we're going to show you this ad. It's overall, it's not the best ad. It's not the ad most likely to be clicked on. But for you, we're going to go to this less popular ad and sort of take that analytical risk because based on your profile, the model is predicting you're more likely to click on this ad. The result, according to the client, it was a 25% increase in response rate, which translated to a 3.6 to 5% reported revenue increase. Based on the revenue they were getting from these ads, that translates to $1 million additional revenue, a rate of $1 million every 19 months. So that increase of revenue comes only from more intelligent, predictively based decision making. No new business model, no new sponsors or ads, no big change to the website behavior, just more intelligent choices. So taking a step back more broadly in terms of marketing applications, there's 3 areas where predictive analytics helps with marketing with regard to when customers are coming, when they're leaving, and what you do in between when you've kind of got them in your wheelhouse. That is to say, response modeling for acquiring customers, for customer acquisition. That's what we've talked about the most so far, targeting direct marketing by way of predicting who's going to respond. What we'll talk about next in a moment is churn modeling, predicting who's leaving in order to target retention offers. And in between is kind of everything else you're trying to do, upsell, cross-sell, make the most value, make the best customer experience, product recommendations, picking which ad, what I just spoke about a second ago. So now moving on to number 2, churn modeling for retention. So in marketing overall, regardless of analytics, regardless of predictive analytics, it's very much a rule of thumb and sort of common wisdom that in general, retaining existing customers is a more valuable endeavor, a better payoff than acquiring new customers, because it tends to be less expensive to retain a customer you have, an existing customer, than to acquire a new one, so as it were, off the street. And you can see this balloon in the middle as your existing customer base, and the acquisition of new customers is air flowing in from the left, and the attrition, defection, loss of customers is the air leaking out to the right. And you can imagine that if you were able to convince some of those departing customers to stay, to retain some more customers, decrease the attrition rate, that is to say, squeeze that nozzle on the right and make this just a little bit tighter so that less air is escaping, how much more quickly would this balloon be expanding? Well, that expansion rate is the growth rate of your customer base. However, retaining customers can be expensive, often requires a hefty discount, a free phone if you're a cell phone company, this kind of thing. Not the kind of expense that you can incur across your entire base of customers. Therefore, by definition, the only effective way to target these efficiently, these retention discounts, is by way of predicting who's leaving. So for example, here's the makings of a decision tree from data with Chase Bank on their mortgage customers, which basically divides their mortgage holders into 2 segments based on the interest rate. So is the interest rate less than 7.94%? So if it's relatively low, go left, that's yes, otherwise go no. And that distinguishes, breaks the customers up into 2 segments with very different defection or churn rates, which in the case of a mortgage is called a prepayment. So risk of prepayment 3.8%. That is to say, a prepayment is because they've defected, they went to a neighboring bank, refinanced the mortgage, and then they paid off your bank all in one fell swoop. They prepaid it, they paid it all off, which means you're not going to get any more of the future interest payments. So you've lost that customer. If the if the interest rate is higher, then you go right, and the risk of defection is 19%, a huge difference just based on that one variable, that one factor. So just briefly for the moment, a real brief overview to get started with decision trees is that same thing as now the top of this tree. Trees in computer science and in machine learning and predictive modeling are upside down, so the root, the beginning of the tree is on the top. And you ask yes/no questions as you go from the top down to one of the endpoints. If the answer is yes, you go left. So by doing that, each customer gets assigned to one of these risk scores on the extremities there: 2.6, 3.4, 9.1%, etc. And you can follow the path from the root, the top of the tree, down to any of these endpoints, and each path like that corresponds to an individual. This egg is to remind me to tell you that yes, what you're seeing here is a predictive model. So when I show a golden egg, it's a predictive model, and the decision tree is one example form of predictive models that takes all the different things known about the customer, considers them together in order to assign the predictive score. So you follow that one path from the top to the bottom, it'll correspond to one so-called business rule like this. If the mortgage is between 67.7 thousand and 183,000, and the interest rate is over 8.7%, and the ratio of the loan to the home value is under 87%, then the probability of prepayment, of defection, is 25.6%, which is relatively high because in this data set the overall defection rate was less than 10%. So you're looking at a customer today, and you can use these types of predictions from a churn model to say, hey, should I offer this customer a discount? Are they at risk of defection? Tomorrow, will they still be, let's say, a subscriber to our magazine, or will we have lost them? Will they have defected? So by the way, this brings up a secondary issue in marketing that comes up, for example, especially with cell phone companies, where a retention offer like this, hey, renew your cell phone contract and you're going to get a free phone, actually has potential to have a very negative side effect, sort of some blowback, inadvertent consequences, where by actually providing this offer to the customer, you've reminded them, and the light bulb goes on over their head that, hey, they just reminded me that I'm up for renewal, that my contract's expiring, so I'm free to defect to a customer. And that may, in some cases, cause you to lose that customer, where just keeping your mouth closed and being silent, you would have otherwise kept them. Those customers are called sleeping dog customers. And in addition to predicting who's at risk of defection, predicting who's going to respond adversely to a retention offer, that is, say, who is a sleeping dog customer, invoking the adage, let sleeping dogs lie, is one of the benefits of so-called uplift modeling or persuasion modeling, the advanced topic of Chapter 7 of my book. So to wrap up, now that we've given the overview of predictive analytics and how it applies to marketing and how it provides value for marketing, most of these concepts apply to other types of business applications and other types of applications for organizations other than businesses. So in general, the way the world works is that organizations treat us and serve us in certain ways. These are some of the action verbs that they do, the operational ways that they affect us every day, with advertising and targeting discounts, approving loans, providing financial advice. Governments assist us, help with education, approve or disapprove applications for benefits. Law enforcement decides who to investigate, how long people will remain incarcerated. Healthcare providers diagnose, treat, etc. And these are the operational actions, decisions that are guided with prediction. Here are the things that are being predicted. So if the previous slide was the things that organizations are doing, these are the things that we're doing as individuals that are being predicted by these organizations. Whether you're going to love, procreate, or divorce, whether you're going to buy, cancel, or click, default on a payment, quit your job, commit a crime or fraud, show symptoms, get a disease, even psychological and mental things like thinking and lying. Many of these, all of these are given more detailed examples in that color insert in the middle of my book, as far as all the different kinds of mini case studies across many organizations doing these things. So that's it. I hope you enjoy the course and the book, and welcome to Predictive Analytics. Thanks a lot.